Hi everyone, so in this video I'm going to talk about another sorting algorithm, which is basically counting short. This sorting algorithm is basically something different from the previous sorting algorithms, like the bubble sort, selection sort, insertion sort, and we see how the sorting algorithms are different, in case of the time complexities and the space complexity of the algorithms. So basically this is a linear sorting algorithm, and the previous ones are the quadratic sorting algorithms. We'll see why it is quadratic, and why those are quadratic, and why this is a linear. uh, so let's get started with the counting short algorithm. So here's the counting short. So here's the counting short. So of course, like the previous videos, in this video also, I am going to like explain the sorting algorithm, and then I will jump into the code, and then also I'll explain the time complexity and the space complexity of the algorithm. So let's get started. Okay, so in case of the counting short, it is genuinely uh, can be can be performed in a small range of values, like from can be performed can be performed in a small range of values, in a small range of values like from 1 to n. 1 to n. Uh, Basically, it is not efficient for the large range of values. Why it is not, you will get to know this in a minute. So, what happens here? Uh, like in the previous sorting algorithms, like bubble sort, selection sort, insertion sort, those are like compression sorting algorithm, compression based sorting algorithm. That means in those algorithms we just compare two elements, and if it satisfies some condition, we'll swap those two elements, right? But in this case, it is genuinely not like those algorithms. It is something different. It uses some hashing technique, like hashing concept, to store the count of the element in another array, and then depending on that, like the another array will perform some task to sort the list or the array. All right, so let's start with the example. Like explain how the counting should works. Let's We have a list, or like it is like 2 1 3 1 2 4 and 5. Suppose we have a list of numbers from 1 to 5. The range is 1 to 5. Okay, this is the range, right? This is the range for this list. Okay, so generally it has a list that is okay. Now, so it has, suppose, n elements, right? It has n elements. So how counting should work? Let's go to the second page. So the list is 2 1 uh, 2 1 3 1 4 5. 2 1 3 1 4 5, right? We'll take another count, like array, you can say. Suppose we'll take a count array, where we store the count of the elements, like how many elements um, are repeating and how many elements are not, like the number of elements uh, will store in this like array, or you can say list. Like this is the index of this array, or you can say list: 0 1 2 3 and 4, right? uh, and here's a 5. We need 5 because here's a 5 this was number 5, right? So we also need 5. Need 5. Okay. So what we'll do, we'll start from this one. We'll start from this one. We start from this index. Okay, the first index. So here, what element we have? We have 2, right? So in the count, we go to the second index because we have 2 here in the list. So in the second index, we also go to the uh, second index. So in the count, we increase. But first of all, it has all the values are 0. Just first of all the values are 0. We initialize all the values with 0. When 2 encountered, it will go to the count and count array, and it will go to the second index, and it will increase its value by 1. Increases value by 1. So it will be now 1. Now it will go to the second index, like in the list. It will say, okay, the element is 1. So in the count array, it will go to the 1 index, and it will increase its value by 1. Increases value by 1. Now it will go to the this index number 2 of the list. The element is 3. So in the count array, we'll go to the index number 3, and we'll increment its value by 1, right? This value by 1. So it will be now 1. Now we have a element like index number 3 in the list. This one, right? This one. So in the count array also, we'll go to the index number 1 and increase its value by 1. This will increase its value by 1. That means 2. Now in the 4, likewise, we'll go to the 4. We have this. Go to the count array, go to the index number 4, and we increase value by 1. That means we're taking count of how many elements, like what elements are there, like in how many numbers. Okay, here we go. This value, now we just increase value by 1, and in the 5, we'll go. This is 5. And let's go. We'll increase this value by 1, right? Increase value by 1. So that's the count array. That's the count array, right? That's the count array. Now, now that this second step, like basically in the third step, you can actually say what is the first step? First step is like initializing the count array with zeros. Second step is like putting the value, like incrementing the values in the count array, and this now is the step 3. This is the step 1 and 2. Now it is the step 3. What is the step 3? Step 3, in case of step 3, basically in case of the sorted list, suppose let's see if this list is sorted, how it looks. Let's see if this is sorted, how it looks. It will look like this actually. If we show the sorted list would look like, let's do it in a green. Sorted list, it's not green actually. Sorted list, okay, it will be 1 1 2 3 4 and 5, right? So this is the index 0, this is the index 1, this is the index 2, this is the 3 4 and 5. So what we need that from 0 to 1, here is 1 1. From from 1 to 2 to 2, it is 2. From 3 to 3, it is 3. From 4 to 4, it is 4. And from 5 to 5, it is 5. We need that, right? the shorted list. So what we'll do, we'll genuinely, what we'll do, we'll take the adjacent element sum in the count array. We'll take the adjacent element sum in the count array. What we'll do, because to find the range from where to where we need 1. If here we need 0 to 1, right? To get from where to where we need 1, we'll do that. How will do that? Let's see here. Like what we'll do, we'll take this one sum, this two sum, which is basically 0 plus 2 is basically 2, 2, and we'll store it in here, right? Again, we took this two elements sum, then is 2 plus 1, it will be 3, and we will store it here. Then after doing this, what will be our new count array? Our new count array will be like step 3, new count array would be this one. Let's make a box. Yep. And so it will be 0. Here we have 0, 2, 1, 1, 1, 1, right? So we'll take this two elements sum, we'll store it here. That means 0 plus 2, 2 will store it here. So it already 2, so it was okay. Now we'll take this two elements sum, and we'll store it here. If you store it here, 2 plus 1, 3. So if we store it here, it will be 3. Okay. Now we'll take this two elements sum, we'll store it here. 3 plus 1, 4. Now it will be 4. I'll take this two elements sum, basically 5. So it will be 5. Now I'll take this two elements sum, it will be 6. So we'll store it here. Is 6. Okay. This is the new count array after doing it like cumulative basically sum of the adjacent elements, right? If you can't see it, yeah, now you can see it, I guess, right? Okay, so we get it. Now how to get a shorted list from the count array? What we'll do in step 4, okay, in step 4 we have a count array like this, right? The count array like this, 0, 0, 2, 3, 4, 5, 6, right? 0, 2, 3, 4, 5, and 6, right? And we have a list like 2, 1, 3, 1, 4, 5, right? 2, 1, 3, 1, 4, 5. Okay, so basically now what we'll do, we'll start from the last of the list. From here we'll start. Okay, from here we'll start. And what we'll do, and what is the index of this? It is 0, 1, 2, 3, 4, and 5. We'll start from this, from the list here, last of the list. So what will happen, we'll start from here, and is 5, right? So this here is shorted list. Here we are writing here shorted list, and shall the same size of the list. Of course, it will not grow. Could it grow? 1, 2, 3, 4, 5, 6. So 1, 2, 3, 4, 5, 6. Yeah, same size, and it has indexes like this: 0, 1, 2, 3, 4, and 5. Okay, so it is now in this index. So since it is now fifth index, it will point to the fifth index in the count array. It will point to the fifth index in the count array. So now it will point to the fifth index in the count array. This one. It means this one. And here we have 6. But in the shorted list, we don't have any sixth index. So what we'll do? Generally, we have to do 6 minus 1. That is fifth index. Whatever we get in the count array, we have to we have to decrease it by 1, and thus we'll get our position in the shorted list. Our 6 minus 1 is 5. So it is referring to this position. And in this position, what will store? Will store this value, fifth value. That means it is telling where we'll store this 5 in the sorted list. And it is saying we'll store the fifth element in the fifth position in the sorted list. So it will store the fifth 5 in the fifth position in the sorted list. That means if I write in black, it would be this one 5. Now it will go to the next like next element in the list, and it would be from the backward. Yeah, from the backward, this one, fourth. So it will point to this one, and it is now pointing to the fourth, this one, and it has value fifth. So 5 minus 1 is 4. So now it is point to this one, this index, and it will store 4 value here. It will store 4 value. Likewise, it will now go to this index, and this is referring to this. It has a value 4. 4 minus 1 is 3. So it will referring to this index, and it will store the value 3. Likewise, it will store the value. It has in the next we have a 2. Okay, it is 1, right? Here is a 1. Okay, so it has 1. We missed 1 actually. Okay, it has 1. Missed 1. So it is 1. After 4 we have 1. I thought it is comma. Sorry for that. So it is 1. So 1 is referred to this, and it has 2. So 2 minus 1 is 1. So it refers to this, and okay, I forgot something. I forgot to tell. So when it's storing the value, after that it will decrease. It will decrease the counts, like count by 1. It will decrease the count by 1. That means it is decreased by 1 after storing it in the sorted list. It will decrease it by 1. Then it is now be 4, 35. 6 minus 1 is 5, and it will be decreased, and it would be now 4, and 3, we referred 3, right? So it would decrease. So first of all, let's talk about 1. 1 will refer to here. It will be 2. 2 minus 1 is 1. So it will refer here, and it will store 1 in this array. So it will for 1, and it will be decreased by 1. So it will be now 1. Now 1. Okay, now 1. So now into 3. So 3 will refer to here. In this one, and this 4 minus 1 is 3. 3 will store 3, and it will decrease by 1. It will decrease by 1. So it will be 3. Okay, 3. So now it will be 1 again. So it will be 1. 1 will refer to this one. Here is the value 1. So 1 minus 1 is 0. It will refer to the value 0. This one 0. It will store the value 1 here. Okay, 1 here, and it will decrease it by 1. So it will be now 0. Now at the first of the list we have a 2. Just 2. The 2 will be refer to this one. We have a 3 here. 3 minus 1 is 2. 3 minus 1 is 2. So it will refer here. Here, and this would store 2 here, like we write in black. So it will be 2 here. Okay, 2 here. So now the array is sorted. Now the whole array is sorted. Okay. So that's how the sorting of the sorting in the counting sort will work. Of course, it is little bit of lengthy type of thing. First of all, we have to make a count array. We have to initialize with 0, and then we have to increment it depending on the how many elements we have, and then from the count array we have to generate the sorted list. Sorted list in another array. So of course it will take some auxiliary space. It can't be constant, and but its time complexity is really good. It is basically, you can say, linear time complexity. It would solve it in linear time complexity. How it will solve it in linear complexity, we'll check it. Okay, we'll check it. So let's talk about the time complexity. I hope you understand these things, and it will be more clear when we will do the coding part. So for now, let's talk about its time complexity. Let's talk about its time complexity. Okay, time complexity. So in the step one, what do we do? Initialize. We initialize count with 0, and the basically the size of the list is n, and the size of the count is, suppose we let the size of the count is m. Okay, the size of the list is n and the size of the count is m. So okay, uh, if we initialize the count with 0, suppose we have m elements and we are initializing with 0. Okay, we are initializing with 0. So how much time it will take? It will m time, because of m time, right? Because we have m elements and each initializing with 0. So we'll take time taken for this is time complexity. Time complexity, it will be because of m. Again, in the step 2, we're initializing the count with basically what are we doing? We're traversing through the list. We're traversing through the list and incrementing the count. So where we're traversing through the list. Traversing through list through list to increment count. So here the time complexity will be time complexity. What will be time complexity? You can answer it. It is big of n. Okay, it is big of n. So for the step 1, it is big of m. For step 2, it is big of n. And the step 3, what will have? The step 3, in the step 3, like this one is the step 3. Step 3, we are traversing through the list. Again, we are traversing the list. This one, then this one, then this one, right? So again, we are traversing the list to make the shortest list. So what we're doing, we're traversing through list to make the shortest list. Okay, to make the shortest list. Traversing through the list to make the shortest list. Okay, so that means it has a time complexity of big of n, because list has a size of n. So that's the 3 steps, right? That's the whole step. That's the whole like working of the counting shot. So if we add all the time complexities, so total time complexity, you can say total time complexity. We are in all the step 1, step 2, step 3 is time complexity. That means because first of all, because m, I guess, because m, yep, because m plus because n plus because n. That means you can say it is because 2n plus m. So if you remove the constants, it will generally become because n plus m. This is the total time complexity of a counting shot algorithm. Okay, uh, that is great. Actually, it is basically linear, you can say. It is far better than the bubble shot, selection shot, and the insertion shot algorithms. But where it lacks is because of this small range, and because of the space complexity. Okay, so how let's first of all talk about this space complexity. Then we'll see how it lacks when we give us large range of values in the counting shot. Okay, so let's see, first of all we see the space complexity. Space complexity. Okay, space complexity. So if we talk about the space complexity of the counting shot, it will be because we need two auxiliary spaces. Right, one is for the shorted list, like the this shorted list, this is what we have at the last, has the uh, same length, like as the this list, as this list size, and also need a auxiliary like space of auxiliary like a another temporary array of size m, this space of size m. Okay, that means we need two sizes. That means it's temporary. That means we need first of all a count array, its sizes m, plus a shorted array size n. That means its space complexity will become big of n plus m. So it is same as this time complexity actually. And in the previous sorting algorithms, we see uh, that basically we saw that the space complexities are constant, right? So of course, in case of the space complexity, those algorithms are better, but in case of the time complexity, this algorithm is better, far better. Now let's see why the counting shot is not efficient in case of the large input, like the large range of values. Suppose you have a input of simply 1, 10, 11, and suppose 300 and 400. Okay, in this case, just think of it, how much, how big count, like how big the size of the count array. It will be very big, right? It will be very big, and if you have to want to initialize it with 0, in that case only you need 300 steps, like 300 iterations will be there. So it will be very tedious, right? It will be very tedious. Even you are seeing that here we have only n plus m time complexity, but if you want to short this with a count shot, that would be very bad, that would take lots of time than the bubble shot, section shot, insertion shot. That's why, because of the like the sizes, because it will create a size, uh, like size with the largest, so this is the largest, right? This is the largest possible element in this list, right? So it will create the count array with size 400. Okay, size 400. So this will also bad for the space complexity, and since we are traversing to the count array, that's why it is also bad for, in the case of the space time complexity, you can say. Okay, so that's the thing, that's the explanation of the counting shot algorithm. I hope you understand it. Now let's jump into the code of the counting shot. It will be more, you'll be more like understand this counting shot while you uh, watch the code of this counting shot. So let's jump into that. Okay, we're now in my Replit account, and we'll create a REPL in my CodaGo folder. Let's create that, the sorting folder, and we'll create a REPL named counting shot. We use the programming language Java, and name is counting shot. Of course, it will take a little bit of time. Yeah, let's start with the code. So let's first create a array. Here are new int and we'll initialize an array with some numbers. Suppose we have 2, 3, 1, 1, 4, like 5, 2, 1, 4, and 3. We have this, right? So what to do? Uh, let's since we are creating it without the prior knowledge of what is the biggest number in the array, that means the size of the count short. If you give it explicitly by myself, then it will also work actually. But we don't want to want that. We don't want to do that. What we want, that the program will actually uh, can get the size of the count array. How will do that? We'll take the largest element in the array, right? That would be the size of the count array. So how could you get the largest element of this array? Largest Finding the largest element in the ARR array to for the counts size. Okay, so how to do that? Let's also create an variable for the iteration. It's really I, and here we are creating I equals 0, I is less than ARR dot length, and I plus plus. And now we'll give a condition here, which is basically ARR of and here also the size, count size. Suppose we are giving here count size, or which is basically m, right? M equal to ARR of 0, because we first assuming this is the last thing, assuming first element is the largest element. Okay, now I'm saying if m is smaller than the ARR of I, we start with 1 here, so already have m equal to ARR of 0. If this happens, then m equal to ARR of I. So now we get the size of the count array. So let's like create the count array and with the size m. So int count, int the size m. We're passing the size, creating the count array, creating the count array with size m. Now let's initialize the count array with 0 by 0. Let's initialize the count array with zeros. Okay, so how could we initialize it? We'll iterate our loop of count size, or you can say m, and I plus plus, and we'll do count I equal to 0. Okay, now what we'll do, we'll traverse to the list of elements like in the ARR array, and we'll increment the count array depending upon the how many long elements are there, what element have how many numbers. Like here one has 2 times, so the count will increment to 2 at the index 1 in the count array actually. So like incrementing, what will say, incrementing the count array. So it will be 4, I equals 0, I is and the error dot length, basically the size n. If you want to relate with the explanation, should be, yeah, now equal to 0 here dot length. And now what we'll do in the count, we want to go to the that index, like uh, and basically the size is actually m plus 1, because whatever like whatever array we are getting, we're incrementing it by plus 1. Why we're incrementing with plus 1? There's a reason behind it, like with the code. So okay, so here uh, in this case, if you have a, if the highest number is 5, I'm going to 5. Okay, that's okay actually, right? Here the highest number is 5, so it's traversing to the in 0 1 2 4 and 5. That's fine, there's no issue in here. Yeah, there's no issue, I don't see any issue here. Yeah, that's fine. So this m is good. Okay, m is good, but this from 0 to if it's a 5 elements we are getting, so it will be 0 to 4, right? 0 to 4, so that's why we have to give m plus 1. We're getting it, no? What I'm trying to say, I'm trying to say that, like if we have, like if we have m elements, like if we have m elements, explain it. If we have m, like if you're storing, if the size of an array is m, size is m, and we store, suppose size is 5, so it will be indexed, will be 0 1 2 3 4. There's a 5 elements. But what we want, if we have a 5 elements like here, what do you want if we have a 5 elements, like here we have a 5 elements, right? But how many elements we have here? 1 2 3 4 5 6. One greater, the count size is one greater than list. That's why greater than not the list, but the maximum element is, the maximum element is 5, right? Maximum 5, so it is 5 plus 1 6. That's why it is 1 2 3 4 5 6. That's why here also it is m plus 1. Okay, maximum elements length, and the maximum largest element plus 1 is the size of the count array. Okay, and here we'll do arr uh, arr of I. We're going there and we're incrementing it, okay, by 1. Now we incremented it, let's check it out. Let's check it out by printing it, printing the array. For now it is not sorted, but let's see how the count array will look like. Count array is m, size is m, right? M and I plus plus, and it will be system dot out dot print and count of I, and let's run it, and it will be 0 2 2 2 because there is no zeros here, so it will be 0. For 1 it will be 2 ones, so 2, 2 twos, so 2, 2 threes, so 2, and 4 is 1, and 5 should be 1. Okay, so we are giving this m plus 1 actually. Count as of a size m plus 1, that's why you have to give m plus 1. So the whole thing, not the whole thing, 2 0 2 2 2 1 1. So it is correct. The for now the count that is correct. Now we have to like sum the additional elements in the count array and like update the count array. Now what to do? Update the count array by summing up. Update the count array by summing up. Summing it up. Summing up. How to do it? We'll start from 1 I equal to 0, and we'll go till count dot length minus 1. And why is minus 1? Because it adds elements like the present element plus the next element. So if you go to the last element, then how could you get the next element? You don't have the next element. That's why we only have to traverse through that length of the count element minus 1. Okay, so what we'll do, here we have to make count of I plus 1 is equal to count of I plus count of I plus 1. Okay, so now if we print the count array, how it will look like? Okay, it will look like 0 2 4 6 7 8. Actually true, it is actually right, correct. Good. Okay, so now let's create the sorted array. So sorted array, sorted arr, sorted arr also have a size of the list, right? So new int, and it has a size of arr dot length. And now we'll we'll create the not create, putting the values in the sorted array, putting the values in the sorted array. So, and we'll traverse from the last of the list to the first. So it will be I equal to arr dot length minus 1, and I is greater than equal to 0, and we'll do I minus minus, because it traversing from backward of the array arr. So what I have to do, from the array, like here, if you put this one in the step 4, actually we are if we have the index, like in case of the last index, go to here, yeah, if you have the last index, like last index of the list here, if you have a here, okay, last index, so it will be the last element of the list will be the index of the count, last index of the count. So what will do, the count has the index of the list, that means arr of I, right, arr of I, and its minus value, and whatever is its minus value will be the index of the sorted list, right? It will be the index of the sorted list. Whatever its minus value, this is the minus value, it is the index of the sorted list, sorted arr. And here we will store, here what will store, here will store the list value, this one. So it will store arr of I, right? And after the initialization in the sorted array, we'll decrement the count array, will decrement, will decrease this one, right? In the while I'm explaining it, decrease this one, right? Then we'll decrease the count array, that means we'll decrease the count, that means present count, that means we'll decrease count arr of I, decrease it, right? So now if we have to print the sorted array, so this is now completed. Now we'll do the sorted array dot length, printing in the sorted array. Let's run it. I think it should work. Yeah, we got a sorted array, right? So that's how it works. Got a sorted array is 1 1 2 2 3 3 4 5. So of course I talked about how the accounting works, the code of the accounting shot, the time space type accounting shot. And the upcoming videos also I will be discuss the stability of the all the shorting algorithms, and also like when to use what shorting algorithm and all the other things. So stay tuned for that. And if you like the video, share the video with your friends, like subscribe to the channel, share it on Twitter, LinkedIn, and share if you have a community, so people can benefit from here. And if you want to make a suggestion, you can make it in the comment section. And also, if you're learning in public, take a screenshot and share it in public, share it in any platform, it can be Instagram, it can be Twitter, it can be LinkedIn. That'll be great. And I'll be glad. And if you're sharing it, share it with the hashtag learning with Ronak. And so that's it for today. See you in the next video. Thank you for watching. Bye bye.